All right, so we're going to start with section 3.2. We're going to be sketching graphs of equations today, which can be done two ways. The easy way is the graphing calculator, but it's the more expensive way. I mean, graphing calculators are like $100. I sent you guys an email with like the older version. I got this, I believe, in college, and I graduated college in 2012. So I probably got this in like 2008. Still works great. So like if you think about it, it's worth the expense, especially if you're going to be planning on going to college. You'll have to take math up until probably maybe like your sophomore year. You'll probably have to take like at least 2 math classes when you're in college if you plan on going to like even a liberal arts school. They'll still make you take some sort of math. In order to get to college, you're going to have to take some sort of test that will have math on it. Even if you're planning on going into the military, you'll be taking some sort of test. And most of these tests will allow you to use graphing calculators. And for problems that ask you about graphs or anything like that, this does it for you. No math required. So if you're thinking about this like right now and you're like, I don't really like to do math because it's kind of difficult. I usually get the answers wrong when I have to do all of these things. This does it for you. So if you can, I suggest trying to get this. If not, TI-84, the Texas Instruments Company, has a free trial online. So you just go to like Texas Instruments, you can just Google it, and you can download it to your Chromebook. And after 90 days, they'll make you pay for it. But you can use it for 90 days, and then like say like if you are working and you know you can maybe save up for one. You can, I know that's probably the last thing you would want to spend your money on is a graphing calculator, but I don't know. If you're like, wow, it's worth $100 so I can do all of this in the calculator instead of having to do any math, it might be worth it for you. Other people might not mind doing the math part of it, but I'm going to show you both ways, how to do it by hand and how to use the graphing calculator as well. So today we're going to be sketching graphs of equations, and the first example is saying to sketch the equation 3x minus y equals 2. The first thing you're going to want to do is always take every equation and solve it for y. So 3x minus y equals 2 cannot be put into your graphing calculator because your graphing calculator interprets everything as y equals. So in order to put anything in here, you first will have to solve this thing for y. So I know they do it over here, but I'm going to do it again just so you can see. If I'm solving this thing for y, I have 2 options. I can either move the 3x to the other side, or I can take the y and move it to the other side. It's up to you what you prefer. This one's kind of interesting because it's a minus y, which is going to be a little weird in the end. But I'm going to keep the y where it's at. I'm going to move the 3x. When I move the 3x, I would have to subtract both sides by 3x. These go away. Careful here, this negative is still going to be here. This says negative y equals either 2 minus 3x, 2 minus 3x, or you can also flip this around if you want it to be in like slope-intercept form. If you flip this 3x has the negative attached to it, so it would be a negative 3x. This is a positive 2 because there's nothing to the left of it, which means it would be positive. So it's the same thing as negative 3x plus 2. It's up to you. Because I'm a math teacher and we prefer it this way, I'm going to write it that way. But 2 minus 3x is still correct. Now, this cannot be put in your graphing calculator yet either because it says negative y. In order to get rid of this negative, this is like a negative 1 times y. What do you think we can do to get rid of that negative? Yeah, and we're going to divide everything by what number to turn it into a positive 1? Yep, we're going to divide everything by negative 1. When you divide or multiply by negative 1, it takes everything and turns it into the opposite of what it is. So this is going to be, I'll just finish it over here, y equals negative 3x divided by negative 1 is a positive 3x. 2 divided by negative 1 is negative 2. So this is the equation that you would then be able to put in your graphing calculator. You would hit y equals on your graphing calculator. You would put 3x minus 2 in there, hit second graph, and then you would be able to see this table that is up here. If you don't have a graphing calculator, then what you have to do is take all of these x values, that's a lot of work, put them all into x separately, multiply them by 3, and then subtract 2 to get all of the y values that go along with it. After you got all of those points, then you would take those points and you would have to plot them on the graph to graph that line. So it takes time. And depending on how many points I give you, the more time it's going to take and the more math you will have to do. Now, linear equations are equations that we spend a whole ton of time in Algebra 1 doing. Like, you might remember how to graph this without a table. You might realize, okay, well, this equation starts at -2 on the y-axis because that's going to be our y-intercept. And you might remember that since that 3 in front of the x is the slope, to get from one point to the next, you would just go up 1, 2, 3 over 1, 1, 2, 3 over 1, and plot the points. You might remember that, and that is another way to graph as well. However, the next equation, we are not really so sure how to do yet. This is where Algebra 2 really starts. So I'm going to clear this and move down to this next one, and I'll show you how to do this with your graphing calculator, because this one's a little bit more difficult. So again, it says sketch the graph of this. Well, whether you have a graphing calculator or not, you're not going to be able to really do this unless it's solved for y. So right now, it says -x squared. And again, this work is right here. I'm just going to do it again so you can see. -x squared plus 2x plus y equals 0. And in order to graph this, in order to get a table, we have to have this thing solved for y. You have two options. Where the y is, it might make more sense to you to leave it where it is and move this and move that to the other side. Or you can leave this up where it is and move this y to that side. But if you move this y, you'd have to subtract, and then you're going to be left with a -y, and it just gets confusing. So I'm going to take these two things and move them to the right. To do that, you do the opposite of what it is. So like if it's a negative, you would add. If it's a minus, you would add. If it's a positive, you would subtract. So to move -x squared to this side, I'm going to add x squared. When I do that, these go away, and I'm left with 2x plus y equals x squared. The next thing I'm going to do is move the 2x to the right-hand side. What would I do to move that? It's a positive. What would I do to move that? Hear it, I think. Yeah, subtract. So it's subtract 2x, and the equation is y equals x squared minus 2x. This is what we are going to use either in our graphing calculator or we would use to do this by hand. So let me show you how you would use the graphing calculator to get this whole table up here. Open up the graphing calculator, which again, it's the TI SmartView CE for the TI 84 Plus family. Free software they give you for 90 days. If you want to do, I wish we had instead of full year math classes. If it was just a semester, you might be able to, start it now and squeeze it in. But if you want to get this on your Chromebook or computer at home or whatever, just download this and continue with the free trial. It'll shut off after you are done with the trial. And if you want to buy it on your computer, that's fine, or just buy a calculator, that works too. So when I open this up, I'm going to put into the y equals screen the equation here, x squared minus 2x. So on my calculator, top left-hand corner is y equals. I'm going to clear out what I had in there from yesterday, and I'm going to put x squared minus 2x. And then I'm going to hit second graph, and it's going to open up the table. Now, yesterday, I was going up and down, scrolling through, and these numbers are the ones that I need. I need -2, -1, 0, 1, 2, 3, and 4. So I'm just going to scroll down. Here's the first number I would need, -2, 8. So this is already here for us, but we can see it again. When x is -2, y is 8. When x is -1, y is 3. When x is 0, y is 0. When x is 1, y is -1, and so on. So from there, you could get your table to see what the values are. Once you have your x and y numbers, each x pairs with each y to create an ordered pair. So if I was to then graph this, I would graph -2 on x, and then I would go up to 8 on y and make a point. I would go to -1 on x, up to 3 to make a point. 0, 0. Oh wait, the x-axis is right here. 0, 0 is right here. 1, -1 down here. 2 zeros right here. 3, 3, and 4, 8. And this is called a quadratic equation, a quadratic function, which is different than a linear. Linear is a straight line. Quadratics are parabolas. They kind of look like valleys or hills, a U-shaped graph. And you're supposed to connect the points here. If I click graph, then I will be able to see the graph of this, but it's hard for me to copy this graph onto here without having the exact points. So to use the graphing calculator, I pretty much use just the table to get those values, and then I can use the picture just to get an idea of what it looks like, but I'll most likely just use the table of values to get the accurate things. I wouldn't just take a graph and just randomly draw a U on there somewhere. Okay. If you don't have a graphing calculator, here's what you would have to do. So you would have to use this equation 1, 2, 3, 4, 5, 6, 7 times to get the y number. And I would replace the 7 numbers in for x and solve. So if I was just going to show you the first one, let's try x equals -2. I'll take the equation y equals x squared minus 2x, and I'm replacing a -2 in for both of these x's and solving for y. I should get 8 as my answer. When I do this, I'll have -2 squared minus 2 times -2. At this point, if you just have like a regular calculator, not a graphing calculator, you could put this all in, hit enter, and get your answer, and that it'll still work. But you would just, instead of having to just put it in, hit enter, you'll have to do all of this 7 times. -2 squared is 4. 2 times -2 is -4, so it's going to be 4 minus -4. 4 minus -4 is really 4 plus 4, which is 8. So you would get that same answer even if you did it by hand. Moving on to the next one. The next one is sketching the graph of the absolute value of x minus 2. This one is already solved for y, so we don't have to do that first step that we had to do in this one, because it already says y equals. So we're ready to go. 2 options. You either do this by hand. The first x value they want you to find the y for is -2. So using this equation, I would replace in -2 in for x if I was doing this by hand and solve. -2 minus 2 more is -4. And what's the absolute value of -4? 4, positive 4. So this would be 4. And then your solution point would be -2, 4. All right, we would do it again for -1 if we had to do this by hand. -1 minus 2. -1 minus 2 is -3, and the absolute value of -3 is positive 3. So this one would be positive 3. This ordered pair would be -1, 3. If you have a graphing calculator, then you would go over to your calculator again, to the y equals screen, clear out the last equation, and to insert absolute value bars, you have to hit the math button. And if you have a graphing calculator, follow along with me. You move over 1 to number, and it's already at absolute value. It's the first one. Hit enter, and then you put in here x minus 2. And then you could just go to your table, which is second graph, and you can find all the values you would need. So we still need 0, 1, 2, 3, 4, and 5. So anyone who doesn't have a graphing calculator, here are the values you need. Hopefully you can see up here on the board. I would like you to just copy them down. If you have a graphing calculator, practice this so you can get used to the buttons you would need to push to get there. After you copy down the values for 0, 1, 2, 3, 4, and 5, go ahead and plot those points on the graph provided. these down and you get all of the solution points, here's what your graph would look like when you go to graph it. An absolute value equation is a V-shaped graph that comes to a point either at the bottom, creating an actual V, or at the top, maybe creating a point depending on the equation. So this is what this would look like. And for each equation, you are supposed to connect the points. If it's a straight line, like absolute value equations are straight lines on both sides. But if it's a parabola, then you would just make like a curved line through those points. Whatever happens with the points, you connect them, and it will either be a straight line or it will be a curve of some sort. All right, any questions on those so far? All right, moving on to the next section of this is finding x and y intercepts. So this is actually something you did in Algebra 1. You might forget how to do this. And this can be done by hand, and this can also be done with the calculator. Let me show you how you would find this by hand. We're going to find the intercepts of the graph y equals 2x minus 3. So the intercepts means where it crosses the x and y axis. This is the x-axis, this is the y-axis. I want to know where this line is going to cross the x-axis, which is horizontal, and then also where it would cross the y-axis, which is vertical. I'm actually going to do the opposite first. I'm going to graph this first, and then I'm going to come back and find the x and y intercepts so you can see what it looks like first. So this is a linear equation, and in Algebra 1, we learned that this number here, minus 3, is where you would start on the y-axis. So we would move down 1, 2, 3. And if you forget this information, you can also use a table to help you determine where to plot these points. The slope of this line is 2, or 2 over 1, because the number in front of the x is your slope. So from your starting point, you would go up 2, 1, 2, and over 1. Up 2 and over 1. Up 2 and over 1. So this is what your line would look like. When I go to connect this, I know it's going to be so off. Okay, that's the best I can do. But this is what this line looks like. The x and y intercepts are going to be where it crosses the x-axis and where it crosses the y-axis. So this right here, this is the y-axis. This is going to be the y-intercept. And then this point right here, whatever this ends up being, that's going to be the x-intercept. I know this kind of looks like one word, yit, but it should be like x-intercept and y-intercept. So, in order to solve this algebraically, what we will have to do is take the equation y equals 2x minus 3 and use substitution to figure out what the actual answer is. I can see from the graph where it's going to cross the y-axis perfectly, but I'm not sure about the x-intercept. It looks like it's going to be in between numbers. It looks like it's going to be a decimal of some sort. So what we're going to do is use algebra to solve. So first thing we're going to do is find the x-intercept. This box is asking us to find the x-intercept. Well, when you're along the x-axis here, any point that's on the x-axis has a 0 in for y. Now, when you're plotting points, your y number moves the number up or down, moves the point up or down, right? So anything that's on the x-axis has a y value of 0 because it's not going up or down anything. It's just staying there on that horizontal line. So what we're going to do is replace 0 in for y. And the reason we're doing that is because I know that the y value of this point, whatever this point is, I know that it's going to be whatever number it is, comma 0. Because the y-intercept, the x-intercept is going to have 0 in for y. Now I'm going to solve this. I solved this equation for x to see what number this is going to be. To solve this, it's just like a two-step equation. Add 3 to both sides, get 3 equals 2x. Divide by 2, and I get that the x-intercept is 3 over 2, or 1.5. That means that this point right here is 1.5, comma 0. The x-intercept is 1.5, or the x-intercept point, ordered pair, is 1.50. So right here where it says x-intercept, I'm going to put it here as well, 1.5. The y-intercept is the opposite. The y-intercept is when the line crosses the y-axis. And when the line crosses the y-axis, that point there will always have a 0 in for x, because x points move you left or right. Well, if you're staying along this line, then the x value has to be 0. So if we're going to solve this algebraically, y equals 2x minus 3, I'm now going to be replacing 0 in for x to solve it algebraically. Now this one's interesting because you can see what the y-intercept is perfectly, because you can see it completely crosses. Hi! She's virtual today. Tomorrow she'll be back. You can see that it crosses at the y-axis at -3, but just algebraically, 2 times 0 is 0, 0 minus 3 is -3. So your y-intercept is 0, -3. Does that make sense? So you can solve it algebraically. You can also see it from the graph. The only problem with the graph for this one was the x-intercept was a decimal, and you're not going to want to just estimate it to be like, oh, I think it looks around this. You would need to have an exact answer. Okay, so what I want you guys to do now is try the next 3 equations. Oh, wait, no, this is different again. Sorry, these notes are kind of crazy. So the next section is asking us to graph these equations. So if you have graphing calculators, what you would need to do is solve each thing for y first and then put it into y equals. So this one says y equals 4 minus x. You can just put that right into your y equals screen, get some points, and graph it. It says state at least 3 solution points, so I want you guys to have at least 3 points on the graph. This one, though, is not solved for y. So this second one here, I'm short, so I'm going to do this down here. 2y plus 5x equals 6. This one needs to be solved for y first. So in order to put this in the y equals, you will have to take this equation and solve for y first. And to do that, you would first subtract 5x from both sides. And then you would end up dividing by 2. Then I would divide everything by 2, and you would get, you could leave it like this if you want, or you can simplify this. Negative 5x over 2, you can leave it in fraction form, is negative 5 over 2x plus 6 over 2 is 3. So this equation is what I would want you to use for the second one. This one is very similar to the one we did previously. Solve this thing for y and then put that into y equals. And then this one as well is already solved, so you should be good. So some of you are going to be in a situation where you're using your graphing calculator, putting it in, getting some getting some points. And if the table is not given, like this table is already given for you, a good value to start with for a table would be -2, -1, 0, 1, and 2. I know it asks for only 3 points, but sometimes it's good to have a little bit more. So I would suggest using this table for all of these just to see where the graph is. So use -2 to -1 for each one to help you graph these. And then this table is already given. So if you have a graphing calculator, put it into y equals, copy down the values you would need for -2, -1, 0, 1, and 2. If you don't, please use algebra to replace the numbers in for x and solve for y. If you don't want to do that and you want to try and see while you're in class today how to download the TI-84 free software, then I can help you with that as well. So go ahead and take some time to work on these and then we'll go over them. Okay, so let's circle y, and we can do the other stuff with the other side. So let's do negative x squared first. Since it's negative, let's add it. Y equals, and you don't need to make 0, you can put y equals x squared plus 3x, yep? And then you put that into the y equals 3. Yeah, where'd you get that? How do you do they know that you have that? I'm just asking that on drop off the yeah, hit y equals top left. Erase that. Put x. Yep, put x. And then hit this x squared button. Okay. And then hit plus. Great. And then hit x again. And hit second. Unwrap, right? And there's the table. So these are the table values I want you to use. -2, -1, 0, 1, 2. So you just copy the table that I created up there for that one. And then values of ages. Yeah, math. So go back y equals math over 1 and hit enter. And yeah. All right, because we're running out of time, I just quickly went through and put in these points for each one. So you can kind of see what the graphs look like, and these are just sketches. It's not perfect when we do this by hand. But the first one is a linear equation. I have the table here. I have the values. It says state at least 3 solution points. Well, when you have a table, you have a bunch of solution points. So like I could say that -2, 6, -1, 5, and 0, 4 are 3 solution points. But everyone can have different answers because there's infinite solutions for each line. The second one, we solve for y, and that is here. I used this one in my y equals, and I realized that there's going to be like decimals and stuff for some of them, so I skipped over these, and I just plotted -2, 8, 0, 3, and 2, -2 to get that line. And again, you could state any 3 solution points for that. This one is similar to the one from the examples we did together in that you have to solve for y first. When you solve this for y, you should get x squared plus 3x. When I put that into my calculator and I got the table of values I asked you to use, I realized that I only got this side of the parabola. But if you hit second graph, you'll see that it's a parabola and it's symmetrical, so the same points on the opposite side will be the same here. So to get more points, you can just scroll. It's better to have like -3, -4 as well to get this side of it. And then this one, I put y equals the absolute value of x plus 3 into the calculator and got these table of values. And again, it only gave us this one, this one, this one, and that one, which is just like a little part of it. If you hit graph, you'll see that this line goes this way to create the left side of the V-shaped graph there. Okay, so that's it for section 3.2.